Hello and welcome to my Math Companion. In this video, we will look at a more challenging problem involving surface area and volume. So let's begin. The question states that if the ratio between the height and the radius of a cylinder is 3:2 and the cylinder's surface area is given as 150 centimeters squared, then find its radius and height. So in this problem, they have not directly given the radius or the height, but instead they have given us a relation between the two of them, which means that we will have to use simultaneous equations in some way in order to figure out the answer. So first, let us see what they have given us. They have told us that the ratio between the height and radius is 3:2. So we will let r be the radius, h be the height, and s be the surface area. So these are the three variables that we're assigning to three different quantities. So from the question, we know that h is to r, as a ratio between h and r is 3:2. And if a ratio is given like this, we can say, we can write it in terms of a fraction. So we can say that h divided by r is equal to 3 divided by 2. So this ratio and this fraction mean the same thing. So now how do we solve for either r or h here? We will do something called cross multiplication. So we will multiply this h with this 2 and we will multiply the r with the 3 and we will equate both the values. So that means we will get 3 times r is equal to 2 times h, which we get by cross multiplying. So now we can either solve for r in terms of h or h in terms of r. And here we will solve for h in terms of r. So h is 3 by 2 times of r. And in order to do this, we must isolate h, that is remove its coefficient and make it 1. And we do that by dividing by 2 on both sides. So now we know h's value in terms of r, which is very useful in our surface area of a cylinder formula. So just like this, there's a formula for the volume of a cylinder, there's also a formula for the surface area of a cylinder. And that is given by this S, which is the surface area, as we had established earlier, is equal to 2 pi r square plus 2 pi r h. And we can simplify this entire formula by factoring out 2 pi r. Now, what does this mean? Since 2 pi r is seen in both of these terms in the addition, that is, in the first term, it is 2 pi r times r, and in the second addition, it's 2 pi r times h, which means that we can factor out the 2 pi r since it's there in both the terms, and we can write 2 pi r times r plus h. Now, if you were to expand this like any binomial, you would get 2 pi r times r plus 2 pi r times h. So you would get 2 pi r times r plus 2 pi r times h, which is 2 pi r square plus 2 pi r h. Now, where does this formula come from? So here's our cylinder, and d is the diameter, which is 2 times r here, this d. So if we were to take the net of the cylinder, that is, we were to remove these two circles and take this curved portion right over here, this curved portion, and we were to expand it out, we would get actually a rectangle. So this curved portion of the cylinder is in fact a rectangle that has been curved. And we see from the cylinder that this length of the rectangle is the same as the circumference of a circle, right? Because this rectangle has been folded in such a way to form two circles on the top and the bottom. And since these two circles are equal, this circle A and circle B are both equal, we can say that the circumferences are equal, and therefore this will be a rectangle. And the length of this rectangle will be the circumference of the circle, which is given as 2, which is 2 pi r. So 2 pi r is actually the circumference of a circle, and this width of the rectangle is in fact the height of the cylinder. And therefore, since we know the area of a rectangle to be the length times the width, we can say that the area of this rectangle is 2 pi r times h, since 2 pi r is its length and h is its width. Where does this 2 pi r square come from? Well, we have two circles and their areas are equal and each has an area of pi r square. So adding the two areas, we get pi r square plus pi r square, which is 2 pi r square. And that is how this formula comes to be. Let's move on with our problem. So from the previous slide, we know that h is equal to 3r by 2 or 3 by 2 times r. And the surface area of a cylinder is 2 pi r into r plus h. So now we substitute the values of h and s into the above equation. So we know s from the question to be 150 centimeters squared, and we know h to be 3 by 2 r. So we substitute these two values into the equation, and we will have to now solve for the radius. So now we simplify this. So we have to add r and 3 by 2 r, and in order to do that, we need to make the denominators the same. So since this is technically r by 1, we will have to multiply by 2 on the numerator and the denominator to get 2r by 2 plus 3r by 2. And everything else remains the same. Now we add these two, so 2r plus 3r is 5r, and the denominator remains the same, so we get 150 is equal to 2 pi r times 5r by 2. That is, we combined like terms here. And now we can just cancel out these two 2's, since one is being multiplied and one is being divided, and 2 by 2 is simply 1. So now we can write 150 is equal to 5 pi r squared. And now we have to just isolate r, or isolate our variable. So now we see that r square is being multiplied with 5 pi. So 5 pi is the coefficient of r square. In order to remove this coefficient and take it to the other side, we will have to divide them on both sides. Divide by them on both sides of the equation. So first we will divide by 5, and when we divide by 5, we'll get 30 is equal to pi r square, since 5 by 5 is 1. Next we will divide by pi on both sides, and we will get 30 by pi is equal to r square. And now we have successfully isolated r square, since we have moved all of its coefficients to the left hand side of the equation. Now how do we find r? Well, we can take the square root on both sides of the equation, since the exact opposite of squaring is taking the square root. And therefore, we will take the square root on both sides and find that r is equal to the square root of 30 by pi, 30 divided by pi. And when we evaluate this on a calculator, we will get r to be 3.09 centimeters. So we have found its radius. We have found the cylinder's radius, and now we have to find the height. Now, just like solving for any simultaneous equation, we will have to substitute this value of r into our equation, which is h, is our initial equation, that is h is equal to 3 by 2 r. So now we substitute the value and we get h is equal to 3 by 2 times 3.09, since 3.09 is the value of r. And evaluating this entire part in a calculator, we will get h to be 4.64, approximately 4.64 centimeters. Again, note that h and r are not these exact values, they are simply approximates, because they both included pi in their calculations. H included pi in its calculation because it included r's value, which included pi in its calculations previously. So now we have successfully solved the question. The height of the cylinder is approximately 4.64 centimeters and the radius is approximately 3.09 centimeters.